question is from FRQ AP Physics. Third question from 2024. Let's see what's there in the question. The question says that a left end of a uniform beam of mass m and length L is attached to a wall by a hinge as shown in the figure. One end of the string is negligible mass is attached to right end of the beam. The other end of the string is attached to the wall above the hinge at point number 1. So here is the point number 1 where it is attached. The beam remains horizontal. The hinge exerts a force on the beam of magnitude Fh. And angle between the beam and the string, that is theta, is theta 1. The following rectangle represents the beam. On the rectangle, draw and label the forces, not the components, exert on the beam. Draw each force as a distinct arrow starting on and pointing away from the point at which the force is exerted. So basically we have to draw the free body diagram. So the mass is m, and we know that m will be at the center of the mass, which will be at the center. So you can say it mg, or you can call it w also. So as beam is there and a string is there, so this string will put a force in this direction. So you will say that this is theta 1 and there will be a force of tension. Now there is another force, that is the hinge force at the hinge, that will be similar to this because they are in the equilibrium. This rod is in equilibrium, so it will be completely opposite to it. So this is the first part. Now it says the string is then attached lower on the wall at point 2. So the string has been shifted from 1 to 2 and beam remains horizontal. Okay, the beam is still horizontal as shown in the figure. The angle between the beam and the string is now theta 2. So now this is theta 2. Earlier it was theta 1. And the dashed line represents this. Okay, the magnitude of the tension in the string shown in the figure 1 is Ft1. So here it was Ft1 in the earlier case. The magnitude of the tension in the string is shown in figure 2 is Ft2. So this is Ft2. Indicate which of the following correctly compares with T2 and T1. So we have to tell that which force would be greater. So first understand that if we draw the free body diagram like this, so this force, that is Ft, and this is theta. I'm not taking 1 or 2, it is general Ft and theta. So there will be two components there, like one component will be there and other component will be here, and this will be like Ft cos theta and this will be Ft sin theta. So if it would be like this, so there will be a torque that would be going in this direction, like the torque will be in this direction. So this torque will be length L into Ft sin theta. So this torque, total torque should be same. So if this sin theta, if this theta will decrease, sin theta will also decrease. And if sin theta will decrease, this F have to increase to compensate the torque. So we will say that as the theta will decrease, as the theta 1 is greater than theta 2, the force 2 will be greater than the force 1. So this will be the right answer. And for the explanation, you can write like this. Okay, now the third part. C says, stating the Newton's second law of rotational form derive an expression for the magnitude of the tension in the string. Express your answer in terms of m, theta and physical constant as appropriate. Okay, so we have to calculate it now. Okay, so for calculation you must understand that how we will use the equation. See, we know that one force is downwards and other force is upward, and this will create a clockwise and this will anti-clockwise torque. So we will say here that the summation of the torque will be equals to 0 as we know. So the first torque, like this, from this you can write like this, L by 2 into mg minus because if this is positive we are taking, then other one we will take at negative. So this will, so this is ft sine theta is the force. Okay, ft sine theta, and here mg, and this is L by 2 and this full length is L. So ft is at L equals to 0. So with L and L goes off, we will take that there, ft sine theta will be equals to mg by 2. ft will be now equals to mg by 2 sine theta. So this will be the formula for ft. Okay, now is your derived equation in part C consistent with your justification with part B? C and B. So in C we have discussed this, and in B we have discussed the force which is greater. So yes, we will say that ft equals to mg by 2 sine theta. So if theta is decreasing, sine theta is decreasing, and if sine theta will decrease, denominator is decreasing, so numerator will increase. So ft2 would be greater than ft1 because the theta 2 is smaller than theta 1. Okay, so theta is decreasing, sine theta is decreasing, sine theta is decreasing, denominator is decreasing, the numerator will increase. So you can just write in your language. Okay, then it says the string is cut and the beam begin to rotate about the hinge with negligible friction. So let's see what's happening now. So it is now, this string has been cut and this is now going like this. Okay, it's little messy. I can draw again for you. Okay, so this is L by 2, L by 2. The angular speed of the beam as a function of time. So angular speed is omega, and while the beam falls but before the vertical. So we have to make omega and t graph. So you know the formula. The torque is equals to I omega, I alpha. So the torque here is this, mg. The torque here would be, so we can say that torque is directly proportional to alpha, or we can say alpha is directly proportional to torque, and torque here is how much? like if it will go downwards, the center of mass will go downwards. Actually, this is directly proportional sign, and this is alpha. So alpha is directly proportional to torque. Torque is what? Mg into this distance. So if this is theta, how much is this distance? This will be L by 2 cos theta. Mg L by 2 cos theta. So if this theta is now increasing from 0 to 90 degrees, so we can say that alpha is directly proportional to cos theta. As the theta is increasing from 0 to 90 and cos graph is like this. So if cos graph is like this, it means that the alpha, which is the angular acceleration, that is decreasing, and the slope of this omega and t is alpha. So the graph will be like this, because you can see here that the slope is like this. Slope is decreasing like this because this is the graph of alpha, because alpha is directly proportional to cos theta. So this cos theta would be decreasing like this, up from 0 to 90 degrees. So from here, from 0 to this 90 degrees, or before 90, just before 90, because they have said that it is just becoming the vertical. So this would be the right graph for that. So you have to draw like this. So this is how you have to solve the questions. Hope this video has helped you in solving this question and most of your doubts has been cleared. If you still have some doubts, you can definitely put it into the comment section. Thank you for watching this video.